In coordinate geometry, there are important formulas and concepts for us to revisit before we can move on to a full question. Okay, so pause the video and take this time to actually fill in the blank and check your answers with mine. All right, knowing the distance between 2 points, knowing the midpoint formula, as well as knowing that all straight line can be written in the form of y equal mx plus c. These are all very useful and helpful when it comes to solving. Now I would like to come to the concepts. Okay, when there are two parallel lines, it means that the gradient are the same. So in summary, m1 is equal to m2. The gradient of the two lines will be the same. But when two perpendicular lines, what concept can we use? All right, you can either say m1 multiplied by m2 will give us a -1, or the gradient of 1 is equal to the negative reciprocal of the gradient of the others. Okay, this is something that's important, which is actually usually tested. Why? Because we would like to find the coordinates of an unknown point. In general, there are two different methods. Okay, the first method is only applicable for special shapes like rhombus, parallelogram, square, as well as rectangle, which is the midpoint theorem method. The midpoint of the diagonals of these four special figures will be the same. All right, so I'll say it's the midpoint theorem method. Whereas the more common one will be the intersection of two lines. All right, with the intersection of two lines, you can find the coordinates of an unknown point by solving for simultaneous equation. And last but not least, they will usually ask you to find the area of the rectilinear figure that is given in the question. So we can make use of the shoelace method in anti-clockwise direction. Okay, starting from the first most convenient point. In anti-clockwise direction, move on. And continue. But please remember to rotate back to the first original point. And then you use your top down minus the bottom up to obtain the area that is necessary in the question. Now, with the formula and the concepts I've just recapped, okay, we will try to tackle this sample question. After reading the question, it's always important to insert the useful information into the diagram. I would like the coordinates to be written in the diagram. Likewise, the equation of AD, I would like to rewrite in the form y equal mx plus c. And last but not least, since that DC is parallel to AB, I make sure I put my arrow to know that I can make use of this fact later. So once all the useful information are in my diagram, I can start solving. For part 1, our job is to find the equation of DC. Okay, DC is the line I have actually highlighted in green. Now, take note, I wouldn't be able to find the gradient of DC since I only know one pair of coordinates. However, DC is related to AB because they are parallel. I'm able to find the gradient of AB, and since they are parallel, the gradient must be the same. So let me find the gradient of AB. I will be able to find both the gradient of the two lines. So after that, using the form y equal mx plus c. Since c lies on the line, I'll use point C, which is 9, 7, to go about solving my y coordinate, or rather my y-intercept. Okay, with that, I will actually gotten the equation of DC. Next, our job is to find the coordinates of D. Notice, for us to find the coordinates of D, the equation of AD in yellow, which is given, as well as the line DC in green, which we found in part 1. D is the intersection of these two. So I can actually solve for simultaneous equation. So I'm going to solve for the intersection by doing the simultaneous equation for DC as well as AD. So after solving for simultaneous equation, I will be able to obtain the coordinates of D. In this case will be 6, 6. Now, I fill in the information for coordinates of D. Our job in part 3 is to find the area of ABCD. Using the shoelace method in anti-clockwise direction, let's go about doing so. I'll start with the most convenient point. In this case is 2, 0. Start with the bottom down first. Multiply the terms and add them together. Then we need to subtract off the bottom up. And add them together. Moving on to part 4. It seems that in part 4, our job is to find the equation of the perpendicular bisector of BC. Let me locate BC. Alright, I will need the perpendicular bisector, meaning it must pass through the midpoint of BC at 90 degrees. So let us find the midpoint of BC followed by the gradient later. So remember, the perpendicular bisector is perpendicular. So if I want to find the gradient of perpendicular bisector, I need to use the negative reciprocal. So in this case, it's negative 1/5. Go about doing so, finding the equation of this perpendicular bisector. And I will be able to obtain my equation to be y equal negative 1/5 x plus 6 1/5. The last part is to find the coordinates of another unknown point. So take note. A, in this case, the figure is a special figure. And I want to find the coordinates of an unknown point. I can make use of the midpoint theorem, the intersection of the diagonals. So let me draw a simple parallelogram and fill in the information that I know. In this case, the unknown point E, let me denote by x, y. And then using the midpoint theorem, I'm going to go about solving so. So the diagonals of BE must be, the midpoint of the diagonals of BE will be equal to the midpoint of the diagonals of AC using the midpoint theorem. Now, let me just go about solving x and y. And I will successfully find the coordinates of the unknown point E for it to be a parallelogram.